Okay, this video is on section 7.2, which is using elimination to solve systems of equations. So the whole point of elimination is you want to get one of the variables to cancel out so that you have the other variable that you can solve for. And it's your choice whether you want, like in this problem, whether we want the A's to cancel or the B's to cancel. It's our choice. But when you set up elimination, you want them stacked on top of one another. You want the A's on top of one another, the B's on top of one another. And what you want to do is you want to multiply either the top equation by a number or multiply the bottom equation by a number or both so that you get these coefficients to be opposites. So we would want to multiply one or both of these equations to make these coefficients opposites, like a positive 10 and a negative 10. Or over here with the B's, we would multiply the top or the bottom equation or both by something to make the leading coefficients here cancel, so like a positive 12 and a negative 12. So it's your choice. You decide, do you want the A's to go away or do you want the B's to go away? Since I already have a positive and a negative, because our goal is to get opposites, I'm going to go with the B's. And so I'm going to multiply the top equation by positive 4, everything in the top equation by a positive 4, because I want this to be a positive 12b. Well, now I'd have to make this a negative 12b in order for them to be opposites. So I would have to multiply this whole bottom equation by a 3. So now my top equation would be 20a plus 12b equals 36. My bottom equation would be 6a minus 12b equals 42. Okay, because whatever you do to one thing, you have to do to all of them. So everything in the top equation has to be multiplied by 4, and everything in the bottom equation is multiplied by 3. And the whole reason we chose those numbers was because I just decided I wanted my B's to cancel. So they had to be opposites here, 12 and negative 12. Once you have opposites, then what you do is you add the equations up. So add vertically. We're going to have 26 A's. The B's go away. And then 36 plus 42, we get 78. Now we have an equation that is just dealing with A's. So to get A alone, divide 78 by 26, and A equals 3. Now, in order to get B, substitute 3 in for A into any of these equations. It doesn't matter. Any of them. So just pick one. I'm going to pick the top equation, just for the heck of it. 5A plus 3B equals 9. That's the equation I'm choosing. So I'm going to substitute a 3 in for A. So 5 times 3 plus 3b equals 9. I'm going to subtract that 15 from 9 and then divide by 3, and b will equal negative 2. And then always put things in alphabetical order. So the A is going to go first and the B is going to go second. And that would be my solution. So you can multiply both equations by some number, or you might be able to get away with multiplying just one of the equations by some number. Let's get another example. Okay, here. Like if we wanted the x's to cancel, I could turn this into a negative 6. This is already a positive 6. That would be easy to do. If I wanted the y's to cancel, I could turn this into a negative 4, and this is a positive 4. That wouldn't be too hard to do either. So you just choose. Do you want the x's to go away or the y's to go away? I'm going to choose the x's, let's say. So I'm going to multiply this by a negative 2. And I'm going to leave the bottom equation alone because here I'll have a negative 6x. This is already a positive 6x. So I'm going to leave the bottom equation alone. So if I multiply all those by negative 2, I get negative 6x minus 4y equals negative 6. This bottom equation is still a 6x plus 4y equals 14. Now that I have opposites, I'm going to add them up, add vertically. So the x's are going to go away. The y's actually also go away on this one. And negative 6 plus 14 is 8. Well, that's weird because 0 does not really equal 8. So what does that mean? That means no solution. If you were to graph these, they would be parallel lines. Because if it has no solution, that means they never touch. The book uses the word inconsistent. You don't need to use inconsistent. You can just say no solution. I'm totally happy with no solution. Okay? All right, let's try this one. Pick either the R's or the S's and try to get one or the other to cancel. It doesn't matter which one. So I'm going to try to get the R's to cancel just for the heck of it. So I already have a positive 4. I can turn this into a negative 4 if I multiply the top equation by negative 2. So that means my top equation would be a negative 4R plus 2S equals negative 2. My bottom equation I'm just leaving alone, 4R minus 2S equals 2. I have opposites, so now I can add. You can only add up the equations when you have opposites in front of one of the variables, at least. So here when I add vertically, I get a 0. Here when I add vertically, I also get a 0. And when I add vertically here, I get a 0. Well, that looks weird, but it's a true statement, right? 0 does equal 0. So it's a true statement. So what that means is that there's infinite solutions. That means you could plug in anything you wanted and it would work. The graph, here, let me write this down. Of infinite solutions would be overlapping lines. So it'd be like, one line here and the other line would be exactly overlapping it, so they have infinite solutions. So that is when something equals something. So you might be doing the problem and you might wind up with 3 equals 3 or 5 equals 5 or 0 equals 0. Those are all true statements, so it's infinite solutions. On the last example, 0 did not equal 8. If you get anything not equal to something else, that's no solution. Now, we happen to have opposites on both of these x's and y's, but that's not your goal. You just need to have opposites on one of the variables. See, these are not opposites, but these are. Your goal is to eliminate one of the variables. Let's see. Okay, this will be our last example, word problem. Okay, read through the problem, and maybe you want to pause it so you can read through the problem. We have to form two equations, and I think the easiest way to pick out what goes with what is pick out everything to do with interest. Okay, that's interest. And the other thing that's interest is that you want an annual interest income. So all of this stuff deals with interest. Now we're investing into two different kinds of bonds. So let's define X and Y as our different bonds. So X we'll call the amount invested in the 5.75% bond, and Y will be the amount invested in the 6.25% bond. And we have to figure out how much we should invest in each bond so that we end up with an interest income of $2,400. Okay, so if we put 0.0575 per X and 0.0625 per Y, we should wind up with a total interest income of $2,400. That would be one equation. The other equation would be having to deal with this 39,000 right here. So the other equation has to deal with this 39,000. We're putting $39,000 into two different bonds. We don't know how much is going into each bond. That's what we're trying to figure out. We just know that some combination of bond X and bond Y is $39,000. We're investing $39,000 into bond X and bond Y. So now we're going to solve those two systems of equations. Now I know this section is about elimination, and you could solve this using elimination, but I think it's almost easier to just solve using substitution. So if I quick wrote these out a little bit smaller, okay, and then this other one, let's say we solve it for Y. So Y is going to equal 39,000 minus X. Substitute 39,000 minus X in for Y right here. Okay, so 0.0575x plus 0.0625 times 39,000 minus x equals 2,400. Now you have an equation that deals with x's, so you can solve this equation. If you distribute that through, you would get 2437.5, and distribute that through here, you'd have a negative 0.0625x. Okay, I'm almost running out of time. Keep solving. Okay, and when you divide, x is equal 7,500. And it's asking what's the most that can be invested in this 5.75 bond. That is X. So this would be the most that you would invest in that 5.75 bond. Okay, so the video is done now. You can go and start the homework. Thank you.